So in this lecture, we'll look at the floating point instructions that we have in RISC-V that we can use in programs that we write in RISC. So first of all, let's look at the model that we have for the machine. We are very familiar with this part of the machine right now. That is our CPU that contains our arithmetic unit, that contains our registers. We have been operating with this in the entire time. We have recently looked at the control and status registers when we studied exceptions and interruptions. And now we are introducing this part of the machine that is the FPU, that's the floating point unit. The floating point unit will have 32 F registers and a floating point arithmetic unit. We have not looked a lot into the memory yet. We're going to look at the memory after we study the hardware design for the processor. So let's talk about floating point in RISC-V. RISC-V supports the IEEE 754 single precision and double precision formats for floating point. The RISC-V has a separate set of registers to store the floating point operands from F0 to F31, as the previous picture showed. F0 is not hardwired to 0, is different than in the integer case. Remember, the register 0 always contains 0. In the floating point case, it doesn't. And FCSR is a floating point control and status registers that will set which is the rounding mode that the machine should be using, because remember, the standard has different rounding modes that you can select from, so that's how you're going to select which one you're using. The F extension, so at RISC-V is designed with different types of extensions, and each one of those extensions will have different number of bits for the floating point registers. So the F extension has 32 bit wide floating point registers. Each contains a single precision value. There is a D extension. D stands for double. So the double extension will widen the floating point register to 64 bits and will allow each one of those 64-bit registers to contain either a double or a single precision value. And it depends on the base single precision extension. So you have to have the base single extension F in order to add the double extension. Then there's another extension that is the quad extension, for Q for quad. So the quad extension will widen the floating point registers to 128 bits, and each one of those 128 bits can contain either a single, a double, or a quad precision value. So, floating point instructions in RISC-V. There are different instructions that to work with floating point than with the integer numbers. It's similar to the integer versions, but they operate with the floating point registers. The floating point instructions use the same format as their integer counterparts. For example, the loads use an I type, the stores use an S type, and the arithmetic ones use an R type. What we're going to change is their opcodes that will indicate that they are a floating point instead of an integer operation. So, for example, I can have an FLW. That's a floating point load word. So the floating point load word has exactly the same format as the load word. So it's going to load a single floating point value from memory given by the register RS1. RS1 is an integer register, plus the 12-bit signed immediate into the floating point register RD. So the difference here from the load instruction or the load word instruction is that the destination register is not an integer register. The destination register is a floating point register. I have an FSW that's very similar to the analogous to the FLW. So this is a floating point store word. Again, RS1 is an integer register. The immediate value is treated the same way as in the store word. The difference is that now the source register, the RS2, is not an integer register. It is a floating point register. So this we're going to store a single precision floating point value from the floating point register RS2 into the address given by the integer register S1 plus the immediate value that's specified in the instruction. So floating point load word, floating point store word are very similar to load word and store word. The only difference is that for the load, the destination is a floating point register. For the store, the source is a floating point register. Now let's look at, this animation should, those bars should be white, but we're gonna roll with this. So let's look at the floating point instructions in RISC-V. I have an add instruction, and it can be, each one of those instructions can be single precision or double precision, and I use the .s or the .d to specify the precision. I have sub instructions, I have multiply instructions, I have dividing instructions, and then I have this fx instruction. The fx instruction is a comparison instruction. And the x in the fx in the fx here could be equal, less than, or less or equal than. So I have these three options for comparison. And what this instruction can be single or double. So what I'm specifying here is 6 instructions actually, right? Single or double, and can be equal, less than, or less or equal than. And there is an integer register that is specified in the instruction. And this integer register is, will, after the instructions execute, this integer register will either have the value 0 or the value 1. So the register will be set to 0 if the comparison is false, and will set to 1 if the comparison is true. So the registers that are being compared are floating point registers. So then, once I get that value 0 or 1 into that integer register, I can use branch equal and branch not equal, the integer versions of those instructions, to perform a floating point branch. So a floating point branch always has 2 steps. The first step is the step that does the comparison. So the comparison instruction will put 0 or 1 into an integer register, and then the second step is the one that actually does the branch. I have conversion instructions. So there is the fconvert SW and fconvert DW. So converts a 32-bit signed integer in the register RS1 to a single or double precision floating point value in the destination register. So this is how I convert from integer to floating point. And I have finally a conversion from floating point, so a single or double precision floating point value in FP registers RS1 to a signed 32-bit integer in the integer register RD. So the floating point instructions in RISC-V, let's look at an example. The question is, what does this code do? And if we recall what we just saw, the first instruction is a load, the second instruction is a load, the third instruction is a floating point addition, and the last instruction is a store. So what this instruction is doing, it's loading 2 values from the stack, 2 floating point values from the stack, adding them, and putting the result of the addition into the stack. So this is how I use floating point operation in RISC-V. This term, we do not have labs that are using floating point registers. In the last year, our lab 2, our lab 3, lab 3 I believe, that was one of the early labs, did a fractal simulation. So it was a much more difficult lab than the labs that we are doing this term. So they did this fractal simulation. The fractal simulation used floating point instructions. So when we got to this time of the course last fall, the students had already completed a lab where they have used the floating point instructions. This is not the case this term, but we're going to have several exercises and several work to do in class around floating point representation.